Okay, so we are going to talk about the regular language and their properties. That means, if we have given two regular language, whether they are in union, intersection, concatenation, complement is regular or not. So, this type of properties. So, we want to see whether this regular language is closed under this properties, like whether a given a regular language is closed under regular set or closed under following operation or not: union, intersection, intersectional union, concatenation, then closure, the star, I mean then the complement, intersection, reversal, all these things we are going to study now. So, first question is whether it is closed under union. That means, if we have given two regular set L 1 and L 2, L 1 and L 2, the question is L 1 union L 2 is regular or not. I mean, okay. So, regular means this is we can have a constructive proof for this, but we can use the help of the regular expression to prove this. That is the easier part. I mean, immediate from the regular expression, because if this is a regular language, if these two are regular languages or regular set, that means we have a there is a regular expression for this and there is a regular expression for this. We have a DFA which is accepting this and this. So, then we have a regular expression for these two, then we can have regular expression this R, which is the language of this is nothing but language of R 1 union language of R 2. So, it is L 1 union L 2. So, this is regular. So, once we have a regular expression, then that will corresponding to the epsilon NFA, that will correspond, that means it is a regular language. So, that is straight away coming from the this thing regular language. Now, even the concatenation, if R 1 and R 2, if L 1 and L 2 is two regular language or regular set, then what about L 1 concatenate L 2? That is also coming from this R 1 R 2. Okay. And this is the language which is accepting L 1 L 2, because by definition of regular expression this is, so this is L 1 concatenate with L 2. Now, closure. If L is regular, so it will corresponding to a regular expression R, then this imply R star is also regular. That means, the language of R star is nothing but the closure. So, this is L star. So, this imply L star is regular set. So, this is with the help of regular expression, which is immediate coming from the construction of regular expression. But we want to have a direct construction of, even the intersection may not be straightforward from here. Now, we want to have a direct construction of the DFA, which will accept this. So, let us try to do that. So, let us take two let L 1 and L 2 be two regular set. Okay. So, that means L 1 will corresponding to a DFA M 1 corresponding to a DFA M 2. So, now we are going to construct. So, say M 1 is say some q 1 sigma 1, or maybe we can assume the same sigma, does not make any difference, delta 1 and then q 1 f 1 and M 2 is q 2 sigma 2 delta 2 f 2. We can take these two are same. Okay. And q 1 q 2 we can assume they have no common I mean q 1 intersection q 2 is empty, because we can always rename the states. Okay, that is always possible. Okay. So, now given this, now we want to construct a DFA which will accept the language L 1 intersection L 2. First of all, this is our, then if we can construct a DFA which is accepting using these two DFA, then we can say L 1 intersection L 2 is regular. Okay. Now, how to construct? So, we choose a M which is q 1 cross q 2 and sigma which is sigma 1 union sigma 2. If sigma 1 sigma 2 are same, then it is just a sigma. Then the delta we have to define, then q 1 comma q 2 and it is f 1 cross f 2. Now, how we define delta? So, it is taking the Cartesian product. So, all states are in the pairwise. If P is a state in M 1 and Q is a state in M 2, then P comma Q are state in M. This is Q say. Okay. And now, what is delta? Delta means, so this is P comma Q or P Q we can say. So, we move so this will be going to delta of P comma A and delta of Q comma A, like this. Anyway, this we are going to define that. Yeah, where delta is delta of P 1 P 2 comma A is nothing but delta 1 of P 1 A and delta 2 of P 2 A. Okay. And for all P 1 P 2, all P 1 from Q 1 and P 2 from Q 2, and A is coming from sigma. I mean, if you have assumed the same sigma, that is fine, no issue. Okay. Now, for this we can easily verify that L of M is nothing but L of M 1 intersection L of M 2, because we are taking the Cartesian product and our this is the final state is F. F is F 1 F 2. So, both the way it has to reach to the, so a string which is, so that means yeah. So, this is the definition. Now, this we can prove it by the so that means delta hat of so this is q 1 q 2, q 1 q 2 comma w, this is nothing but what? This is nothing but delta hat 1 of q 1 w and delta hat, this we can easily prove 2 of q 2 w. Now, this will be belongs to f 1 cross f 2 if and only if this is belongs to f 1 and this is belongs to f 2. Now, this is belongs to f 1 only if the w is coming from L of m 1 and this is belongs to f 2 because this is the string which is we are going to accept. This will be belongs to f 2, that means, if this string is accepted by this DFA, if and only if the this is coming from f 2. So, that is the proof. So, that means, and this is the L of m. So, L of m is basically L of m 1 intersection L of m 2. Okay. We can take an example, then it will be more clear. Okay, we can take one example. Suppose we have m 1. So, this is p q, this is the final state, this is 0, 0 or 1 and this is 1, this is the starting state. So, what is the language accepted by this? This is the language which is having 1 0. So, if we have say 0 1 0, this is also accepting 1, only 0 is accepting 1 0 0 is also accepting 1 or 0 0 0 is accepting or 0 1 1 is accepting. So, like this. Okay. Okay, now, M 2 is say R, then it is say S. So, this is 0, this is 1, this is 0 or 1. Now, we want to construct M. So, for M we need to have how many states? Call the Cartesian product. So, P R P S Q R Q S. So, all the 4. So, this is our M. So, we can have P R P S Q R Q S. Now, which is the final state? Starting state? Starting state is this one. This is Q 1 Q 2 kind of. Now, this is the final state. Now, what are the delta? So, with 1 we go here, with 0 we come here, then with 0 we come here, with 1 we go here, and with that is the delta rule, because the delta of 1, delta of P 1, delta of P 1 is 1 and delta of R 1 is S. So, it is going there. So, you can easily. So, this is the language. So, if this is L of, so L of M is basically L of M 1 intersection L of M 2, because that is the only final state. So, to reach to the final state we have to, so it is either going to both the way we have to reach to the final state in M 1 and in M 2. So, we can take another example. We can take another example. Okay, suppose we have a say we have a we want to construct a DFA language which is W is has even number of S and A is followed by at least one B. So, our sigma is A B this. So, this we can split it into L 1 intersection L 2. So, what is L 1? L 1 is up to this part, even number of ones, and L 2 is A is followed by at least one B, and then we can find the intersection line. So, the L 1 is W, where W has even number of S. Okay. So, what is the so this is a regular language. What is the DFA corresponding to this? We can start with A, and this is the final state. Now, if we have a even number of A's, na, so we can have, or we can make this as a final state. Sorry, this is not a final state. This is B. Now, we can go to A, then with A we can come back here, and if we have a B, we will hop here, and with B we will hop here. This is this language. Now, for this language L2 is A followed by set of followed by, so each A, so L2 each A followed by a at least one B in W, followed by at least one B in W. Okay, so, this is the language. This is also a regular language. You can construct a DFA for this C D E. Now, with A we go here, with B we remain here, followed by a B. So, with with A we go here, A B, and this is our B. So, this is the language which is followed by at least one B. Okay, because if it is A, then we have to go to the dead state. So, now this is this L is, so now we need to find a DFA which is accepting this intersection of this. So, we have to construct that. Okay, so let us just so this is our M1, we will write M1 in the top. So, this is B. So, let me write, this is our M2 and M1 is here. A is the starting state as well as final state, and we have B over here, A even number of 1, even number of A, and we have B over here. Okay. Okay, now we want to combine these two by the construction which we have seen, the Cartesian product. Now, we have to find a M by taking all the states as a Cartesian product. So, this is AC is one state, AD one state, AE one state, BC one state, BD one state, BE one state. So, we will do that. So, we will have all the states AC, AD and AE. We can use some, we need some space AC, AD, or you can AD and AE, and similarly we can have BC, BD, BE. Okay. So, this is the starting state for this. Now, with AC. So, with A we are going to B in M1 and we are C with A we are going to D. So, BD. So, with A we are going here. Now, with B from AC we are going to A and so with B we are going here. Now, who are the final state? Final state is this one, because this is the final state for this is the final state for this is the final state. Now, similarly, with AD with A from we are going to B and D we are going to E. So, from AD we are going to with A we are going here and with B from A we are going to A and from D we are going to E. D we are going to E. Sorry. So, AD na. So, AD. So, A we are going to with B we are going to B and from D we are going to C. So, this is our B. So, similarly, we can compute all this. So, this will be B, this is B, we can easily check this and this is from BD it is going to be A and this is coming here A, it is coming here A, we can verify this easily, this is B. Yeah, so we have all the moves, this we can simplify as this AC, this is the final state, BC, then AD, BD and we have another state over here. So, this is with A we are going here, with B we are hopping here, this is the starting state and with A we are coming here, with B with A we are going here, with A we are going here, this is the dead state we can say like this and with B we are going here. Anyway, so this is the combination of this. So, this is the way we can have. So, this is L of M is nothing but L of M1 intersection L of M2. Now, sorry union intersection. Now, for the union also we can construct a union, we know it is straightforward coming from the regular expression, but we can have a construction for the this thing for the DFA construction for union also we can have. So, suppose we have L1 which is regular. So, we have M1 sigma keeping the same Q1 F1 and we have L2 Q2 delta 2 F2. Now, M Q sigma delta Q1 comma Q2 and F. Now, Q is nothing but Q1 Cartesian product of Q2 and delta is nothing but PQ A which is nothing but delta 1 of PA delta 2 of QA. Okay. So, from here we can extend this delta hat of Q1 Q2 W is nothing but delta 1 hat of Q1 W comma delta 2 hat of Q2 W. Now, if we make this F to be F1 and cross F2, then this both the way we should have a reach to the final state, then it will give us the intersection. But if we choose F to be like this, then we will get the union. Now, if we choose the F to be Q1 cross F2 union F1 cross Q2, sorry, this is our F. Then at least one way, if we can go to the final state, one of this, then we are done. Then in that case, L of m is nothing but L of m1 intersection L of m2. Okay. So, that means we start from PQ, we start from Q1 Q2, this is the starting state for the, then we are going with x in M1. If we, so earlier case in the both the x in M1 and M2 we need to reach to the final state, both the case, but here at least if at least one of these branch is going to the final state of any one of these automata, then we are done. So, that is the construction for union. Okay. So, we will see the more properties on the regular set. Thank you.